lesson 1B, adding and subtracting radicals. We're going to find out how to express an entire radical as a mixed radical and perform adding or subtracting once we've got it down into simplest mixed radical form. So, what are like radicals? They are like terms just like in algebra. So the strategies for simplifying polynomials can be used to simplify the sums and differences, so adding and subtracting radicals. Like terms are like radicals in a sum or difference of radicals have the same radicand and the same index. Those are the two conditions that need to be met in order to be able to add and subtract. So, in my first example here, I see I've got a couple root 3's. So the root 3's I can group together. So I've grouped my root 3's together. Since I've got a couple root 3's, don't forget you've got a hidden coefficient of a positive 1 in front of that root 3. So you're going to add the 4 and the 1 to create your 5. Root 3 stays the same, just as your variable would in polynomials. Your root 2 root 7 does not have anything that is like it or similar, so you cannot add anything else to it. This would be our final answer. We cannot go any further. They are not like radicals. So once we combine them, we must be, first of all, taking a look. We cannot combine them unless they're in their simplest form, which means we cannot add and subtract entire radicals. They must be put into simplest form as a mixed radical. Then we can add and subtract. Let's take a look at a couple examples. So the first example here has everything in root 3. So all I really have to do is take a look at their coefficients, and I'm going to add the coefficients. 5 subtract 9 plus 3 minus 6. And that's going to give me a negative 7 root 3. You keep the root 3, it does not change. Same as on letter B, you've got all root 6's. So in your root 6's, we are now going to be able to add the numbers in front. So I've got a 4, a negative 1, and a negative 8. I add those together, and I'm going to get a negative 5 root 6. Again, they must stay the same, meaning the radicand does not change. Now we have entire radicals on letter C. They are not broken down like A and B were for us. So that means before we can start, we need to break down all of our radicals into simplest form, into a mixed radical. Push pause now so you have time to work on that, and push play when you're ready to continue. Okay, you've had time to work on that, so let's take a look and see what you come up with. So for root 20, we know that root 20 can be broken down into root 5 times root 4. Root 4 is our perfect square, so we're going to take him out, and we get 2 root 5. Root 98, similarly, is going to be root 49 timesing by root 2 to give us 7 root 2. Root 18, I'm going to do over here. Root 18 breaks down into root 9 times root 2, which gives me 3 root 2. Then I've got root 80, which we have seen lots. So root 80 is going to give me root 16 times root 5, which simplifies to 4 root 5. Now I rewrite my equation or my sentence, my expression here. I rewrite it with my simplified form. So now I have root 20 becomes 2 root 5 plus root 98 becomes 7 root 2. And then I've got my root 18, which becomes a positive 3 root 2. And then I add my negative root 80, which became a negative 4 root 5 on the end. So now I add the like radicals together. My like radicals, I've got root 2's here, so I can add their coefficients. So I'm going to have 7 and 3 is a 10 root 2, and the others, we notice, have root 5 and root 5, so I can add their coefficients together. 2 and negative 4 is going to give me a negative 2 root 5. That is our simplified answer. We cannot go any further. That is all we can do with it. Let's move on. Here's some questions for you to practice on. Push pause now so you have time to work on them. Push play again when you are ready to check your answers. Okay, so you can see the first example. They both have root 6. All I'm going to do is I'm going to take my 2 coefficients and I subtract them. I'm going to get 3 root 6. On letter B and letter C, they are not in simplest form, so I must convert them to simplest form. So I've got cube root 128, so that means I need to check out my cube root chart, and I need to divide by perfect cubes. I can divide out a root 64 timesing by cube root 2. I take the answer of cube root, or I solve cube root 64, which gives me a 4, to the cube root of 2, who comes down right beside. Next, I'm going to take negative cube root 16. So that is going to be, I'll just take the cube root 16, we'll subtract in a moment. So cube root 16 breaks down into cube root 8 times cube root 2. Cube root 8 is going to break down into exactly a 2. I bring down my cube root 2 beside it. My last one I have is cube root 54. Cube root 54 breaks down into cube root 27 timesing by cube root 2. Cube root 27 is 3. I bring that in front of cube root 2. Now again, on letter B, I'm going to rewrite what I have as an equation or an expression here. So cube root 128 now becomes 4 to the cube root of 2. I have my cube root 16, which became a 2 cube root 2, and I'm subtracting it. And then I have my cube root 54, and I subtract 3 to the cube root of 2. So this is what I'm left with as an expression. So now, since they are all in cube root 2, I just need to add the coefficients. So I have 4 minus 2 minus 3 is going to give me a minus 1 or a negative 1 cube root 2. Now, do you have to draw the 1? No, it can actually hide. So you can actually write this as negative cube root 2. Both are correct. Let's take a look at letter C now. Okay, for cube root, or for letter C, we also have to break them all down. They're all square roots, so I'm going to divide by perfect squares again. So this is going to break down into root 4 times root 5 to give me 2 root 5. Root 18 is going to break down into root 9 times root 2, which gives me 3 root 2. Then I've got root 45, which is going to break down into root 9 times root 5. And that is going to give me 3 root 5, and I'm adding that. Then I come to my very last section, which is root 50, and root 50 is root 25 times root 2. I break him down. Root 25 is 5. The root 2 slides over beside, and I'm subtracting that. So now I've written it down in the correct order. Now I can group together the things that are like terms or like radicals. So again, I have root 5 and I have root 5. So I'm going to add their numbers in front. So I'm going to get a 5 root 5. Then I've now got root 2. So I'm going to take all the root 2's and I'm going to add their coefficients. So I've got a positive 3 and a negative 5. That's going to give me a negative 2 root 2. So my final answer becomes 5 root 5 minus 2 root 2. Do you have to write it in that order? No. This is also correct to write the negative 2 root 2, and then you can add your positive 5 root 5 at the end. So either or is correct. Moving on, I have my perimeter. These are our problem-solving questions. We're applying what we know. So perimeter is adding all of the sides. So perimeter is going to be side 1 plus side 2 plus side 3. So I have perimeter is going to be root 98 plus root 80 plus 2 root 5. Now 2 root 5 is already broken down. It is a mixed radical in simplest form. So the only two I need to break down are root 98 and root 80. I can break them down into mixed radicals. Root 98 becomes root 49 times root 2. Root 49, I take the perfect root of that, I get 7 root 2. Then I take root 80. Root 80 is going to become root 16 times root 5. We've seen root 80 a lot. The root of 16 is 4 to root 5, and that's a positive. I'm adding, the plus sign comes down. I'm adding again, so now I can stick my 2 root 5, it comes down in my expression. So now I can add all of them together, the ones that are like radicals. Only a couple of them are. I've got root 5 and root 5, so I can add theirs together. The 7 root 2, there's nothing to add to him, so you would leave him by himself. So 7 root 2, and then I'm going to add that to 4 plus 2 is 6 to root 5. So that is your final answer. What can you do? Can you switch it around? Absolutely. So you could write it also like this, 6 root 5 plus 7 root 2. Either way is correct. Moving on to example 3. We've got root 75, negative root 48, root 128, and root 27. And then we have an unknown side here. I do not know how long this side is, but I know the complete perimeter. So how do I find an unknown side? Well, the side is equal to perimeter, subtract all other sides. Well, that means I need to be able to take all my other sides and add them together so I know what I have, so that I can subtract it from my perimeter. So right now they're all in entire radical form. You need to break them down into mixed radical form and simplest form. I will give you a couple moments to do that. Please press pause, and when you're ready, move on. Okay, you've had a couple minutes to look at it and work on this. So root 48 breaks down into negative root 16 times root 3, which is going to give me negative 4 root 3. Root 128 is going to break down into root 64 times root 2, which gives me 8 root 2. Then I must take root 27. Root 27 gives me root 9 times root 3. The root of 9 is 3, and I'm going to stick my root 3 beside him. That is my simplified answer. And up top here, I have root 75. So root 75 is going to break down into root 25 times root 3. We know the root of 25 is 5, and I bring my root 3 down beside it. So now I've completed all of my radicals into simplest form. Now I add them all together. So I'm going to circle them so I know which ones I'm going to add. So I've got root 3 and a root 3, and I have one more root 3. So those are like radicals. I'm going to add all of my root 3's. So what I have here now is a negative 4 plus 3 plus 5. So I'm going to get 4 root 3. So 4 root 3 is adding all of my root 3's together. Then I have an 8 root 2. So I need to stick the 8 root 2 beside. So these are what all of my sides add up to without the question mark, without my unknown side. Now I need to take the perimeter and I need to subtract all those sides. And that's going to give me the unknown side length. So let's do that. Take a couple minutes and subtract those. Let's see how we do this. Since I have a subtraction sign and there's more than one thing I'm subtracting, these must be in brackets. So I need to put brackets there. And why brackets? Because I'm subtracting, and I'm actually going to be multiplying a negative 1 into the bracket. So my perimeter is 3 root 2 minus 5 root 3, and now I'm subtracting by multiplying that negative 1 in. Multiplying the negative 1 to my 4 gives me a negative 4 root 3. Multiplying negative 1 into the 8 gives me a negative 8 root 3. Now I'm going to add all my like radicals together, and that's going to give me my unknown side. So nothing can add to my 3 root 2, so 3 root 2 is all by himself. So I get 3 root 2. Oh, pardon me, that's a root. Where are we here? Okay, so there was a little mistake here. I wrote it down wrong. This is not a root 3. That is actually my 8 root 2 that came from right here. So it's actually an 8 root 2. So yes, I do need to add my root 2's together. So I have my 8 root 2, negative 8 root 2, and at the front I've got my 3 root 2. So I'm going to add both of those together, and I'm going to add the numbers in front. I get a negative 5 root 2. That takes care of my root 2's. These are done. Now I have to take care of my root 3's. I've got a negative 5 root 3 and a negative 4 root 3. Negative 5 plus negative 4 is a negative 9 root 3. This is my final answer for my unknown side. That is my unknown side length. Now, does it have to be written in that order? No. The negative 5 root 2 can be at the end. So I could write it also like this, negative 9 root 3 minusing 5 root 2. Either way is correct. Let's move on to the next example. This is your practice question for perimeter. Again, break down your sides and break them down into simplest mixed radical form, and then add your like radicals together to find your perimeter. Take a couple minutes to do that, press pause to do that, and when you're ready to move on, push play. Okay, so root 13 is already in simplest form. It doesn't break down. So root 13 is by himself. So I have perimeter is equal to root 13 plus root 208 plus root 52. Now root 13 is in simplest form. So he comes down by himself, root 13, and I need to break down root 208 and root 52. So root 52 breaks down into root 4 times root 13. We know the 4 as a root, perfect root, gives us a 2. The root sign disappears, and I add my root 13 sitting beside it. So 52, root 52 gives us 2 root 13. Now I'm going to break down root 208. So root 208 breaks down into root 16 times root 13. We know the root of 16 is 4. I bring my root 13 to sit beside it. So now I have all of my simplest roots. I can put my 4 root 13. That is what my root 208 becomes. And then I'm going to add at the end my root 52, which we simplified to 2 root 13. They all have a root 13 now, which is my like radical. So I'm going to add the numbers in front. Don't forget there's a hiding 1 in front of that first root 13. So I've got 1 plus 4 plus 2 to give me a perimeter of 7 root 13 as a final answer. That is my perimeter. Here's the second practice question for you to work on. Again, it's solving for an unknown side in a triangle. All the sides are unequal. This time it's wanting us to put our answer in the numerical response box. So it says the answer will be in the form a root b. Place the sum of a and b in the numerical response box. So once I find the a root b, I'm going to take a plus b and put my answer in the numerical response box. All right, so in order to do that, where do we start? Break down your entire radicals to lowest term, simplest form, mixed radicals. I'll give you a couple moments. Finish this question. When you're ready to move on and find the answers to see if you did it right, push play. So push pause now, please. Okay, you've had a couple minutes to work on this. Root 108. We have to break this down. Root 108 breaks down into root 36 times root 3. The root of 36 we know is 6, and the root 3 sits beside it. Root 96 is going to break down into root 16 times root 6. Root of 16 is 4. The root 6 sits beside him. So now I've figured out what my simplest form radicals are. So now what I have to do is I need to take and I have to add those together. So my unknown side is going to be equal to my perimeter, subtract my other sides. So now my unknown side is perimeter 10 root 3 plus 4 root 6, subtracting Okay, we need a little bit of room before I can subtract and write my roots down. So I need to erase this stuff for a moment. Let's erase this. So we have a little bit of room to work with. So I can move all of this over. So now I'm going to subtract. I'm going to subtract my other two that I found. So I'm going to subtract 6 root 3 plus 4 root 6, which were my root 108 and root 96. Now, why is it in brackets? Again, because I have a subtraction sign out front, which means I'm actually going to be multiplying by -1. So multiply your -1 into the brackets. All it does is it changes the positive signs to negative signs. So I'm going to rewrite my expression now. My unknown sign is equal to my perimeter, 10 root 3 plus 4 root 6 minus 6 root 3 minus 4 root 6. Now at this point I take a look and I try to group my same or like radicals. I've got a root 3 and a root 3, so I'm going to add the numbers in front. 10 subtracting 6 gives me 4 root 3. And then I'm going to take my other radicals now. They both have a root 6, and I add them together, and they disappear. It gives me 0. So do I write 0 root 6? No, you don't. It disappears completely. You have no root 6 left. So your unknown side is 4 root 3. Our last example here wants us to find the difference in the length between each pair of sides. So difference means subtract. So what I'm going to do here, difference means I'm going to subtract these sides. So SR and PS. So I'm going to take side SR. So I know SR is 10 root 8 centimeters. And PS, I know is root 50 centimeters. Well, root 50 is not broken down, so I need to break root 50 down. And we've done this quite a few times. We know it's root 25 times root 2. The root of 25 is 5. I'm going to stick my root 2 right beside. So now I have my simplified form. So we want to know the difference between these two. Since I'm doing difference, I'm just going to subtract them. Now 10 root 8. 10 root 8 looks like it's already simplified, but it really isn't. We can take the root of 8 and break him down further. So let's break him down again. 10 root 8, the root 8 becomes root 4 times root 2, and this coefficient 10 slides in front. He doesn't disappear, he's attached to the radical. So again, my 10 comes down, and he multiplies by the root of 4, which is 2, and my root 2 on the end slides next to them. My last step for there would be to simplify by multiplying the 10 and the 2, so I get 20 root 2. Now I can add or subtract my radicals. Now how do I know who to subtract? Well, you're subtracting large, subtract small. So I'm taking 20 root 2, subtracting 5 root 2 to give me 15 root 2. So the difference between those two sides in length is 15 root 2. We're going to do the same thing with letter B. You try letter B on your own, press pause now, and press play when you're ready for the answers. Okay, so we now have RQ. I know that RQ is in simplest form. It's 29 root 5. Root 5 cannot be broken down. But then I've got PQ. PQ is 10 root 45. And I know root 45 can be broken down further. So I'm going to break root 45 down. He simplifies to root 9 times root 5. But don't forget, the 10 in front is attached, so he is going to multiply by the root of 9. So I have 10 multiplying by the root of 9, which gives us 3. And then I stick my radical left over, root 5, beside. My last step, like before, was to multiply the coefficients. So I have 30 root 5. Now I have simplified form of both radicals. Now I can find the difference. So now I'm going to take large, subtract small. So I'm going to take my 30 root 5, subtracting 29 root 5, and that's going to give me a difference of 1 root 5. Do you have to show that 1? No, you don't. You can just write root 5. That concludes lesson 1B for adding and subtracting radicals. Now you should be working in your practice book to finish that section.